So this question was asked at wisdom design round, the final round of Zoho. Let's look at it. We are given a linear set of 8 discrete points, numbered from 0 to 8. Two balls are placed on these positions. Cue ball initially at position 0. Target ball initially at position 2. The user provides an integer input k, which represents the number of positions the cue ball attempts to move forward. The objective is to push the target ball to position 8 or beyond by following specific movement rules. The cue ball always moves first. The cue ball attempts to move forward by k positions. The k is the user input. If the target ball lies in the path of the cue ball's movement, the cue ball stops one position before the target ball. The remaining movement steps are transferred to the target ball. If the target is not in the path, the cue ball completes its movement normally. The game is considered successful when the target ball reaches position greater than or equal to 8. Let's look at the test case. Initially, we are given the cue ball. The cue ball is at 0 and the target ball is at 2, 0, 1, 2. I think it's based on array logic. And the input is 5. So look at this. This is 0, right? So 0 will come here. And what's the remaining? 4. Now, 2 moves 4 positions. 1, 2, 3, 4. And 2 dots to be remaining. That's what has happened here. 2 positions are remaining. Now, yeah. Input is 5. Second input is 3. So the gap is 4. So it moves 3 positions. There is still a position left. Only cue ball moves. The target ball is not disturbed. Now input is 4. When 4 is given, it has only one gap. So it hits the target ball and the target ball moves the remaining distance. Now it has reached the target. So it's done. It's completed. It's successful.
So if you look at the problem statement, it is basically a snooker game. So based on the cues and target. Snooker game, it is like carom board, but we have a stick to play with it. So basically what they're saying is, take it as cue and target. The cue hits the target and the target moves. So but when it is hitting it, right, this is target, this is cue. When the cue touches the target, it stops and the cue starts moving. So that's the basic logic of it. But if you feel this cue target are a bit confusing, we can use whatever variables we want, like source, target, first, second, initial, final, whatever. But it all comes down to basic array. Treat it as a basic array problem, right? Manipulating array using indexes. That's what it is. If you start treating it as a basic one, you can come to an idea of how to solve it. So the cue bar should hit the target, but the cue cannot overlap target. If it hits it, the target should cover the remaining distance. For example, it should move five places. It is in the third place, so it is moving up to third place, and it has momentum for 2 more places. It cannot move now. So the target moves the remaining 2 spaces. So that's the basic logic of it. So if you understand this, you can implement it using array logic. So we have only 2 conditions. The cue hits the target, the cue doesn't hit the target. If the input is greater than the gap between the cue and the cue should hit the target. But if the input is lesser than the gap between the cue and the cue doesn't hit the target. So that's the basic idea of it. So let's move to the coding part.
I'm using IntelliJ for coding. Let's name it Snookers. We have 2 balls. Let's find them. What are they? Cue ball at 0 and target ball at 2. So we defined it. And we know that the size is from 0 to 8. So let's declare the size to be 9. And let us store all these positions in an array. Let's call it as board. So we are given the condition. Yes. Puts the target ball to position 8 or beyond. So currently the target ball is at position 0. 2. So it should reach position 8 or above that. So let us make this as our primary condition. So let's use a while loop. Target less than. So we've already declared something for this, right, size. So let us use the same one, size. So if it reaches, I mean, if the target ball reaches 9, it means that it exceeded 8. So that's our primary condition. Now let us look at the test case again. So each time we should print this thing, right, before getting input from the user. So instead of printing it every time, we can call a function and print inside the function. I'll call it, let's say print it, and we should pass the position of the cue ball and target ball. That will be enough. Cue target. So we can define it later. Let's get to the core logic of it first. So we should get input from the user. Let's get input from the user. In, let's say, move, since it is moving positions. But what is the user going to give if there is nothing on the screen? Let's print something on the screen. Now we've got the number of steps to be moved. So how many steps are going to be moved? Let's calculate it. So let's calculate it from the this thing. This case. Where is it here? Initial, leave initial. Input is 5, right? So it hits it. I mean, the cue ball hits the target ball, and the target ball moves the remaining distance. Here, for input 5, the cue ball moves only one position because at the second position there is target ball, so it cannot move. So cue ball can move only up until one step before the target ball, right? So that's one thing to remember. When the target ball moves, the remaining steps to be covered in the steps. That is for input 5, cue ball is moving one step. So there are 4 steps remaining in the steps. So target ball moves 4 steps. So that's the logic. If the target ball is not in the way of the cue ball, it moves all the steps. Like if there are 5 steps remaining between the cue ball and the target ball, the cue ball can move all the 5 steps. So that's the idea. So let's call this steps. Now we are going to be calculating the gap between cue ball and the target ball. Let's call it gap itself. Gap equal to what will be the gap? It is going to be target minus cue, right? So now let's write for the first condition. If the gap is less than the, I mean, if the steps are more than the gap, like if there is 2 gap between Q and target, the steps is 5. The Q cannot complete its movement. It should collide with the target, right? So we're going to be handling that case. For that to happen, gap should be less than steps, and gap should be greater than 0. Sometimes the step can also be equal to the gap. Like the gap can be 3 and steps can be 3. So we can use equal to. So let's use another variable. Let's call it Q move to track the movement of the cue ball. Gap minus 1. So since collision is occurring here, the cue ball moves position till before the target ball. So the gap is target minus Q, right? So like for example, if Q is at 2 and target is at 5, and the steps are 4. Okay. So the gap is 5 minus 2, 3. So the movement should be 3 minus 2, 2 steps, right? So that's what it is, Q move. And now Q position, Q is equal to Q plus Q move, right? 2, it's going to be 2 plus, what is it, 2? It's going to be moving 2 more places. That's it. So Q has completed movement. But the remaining momentum should be transferred to the target ball. So let's use another variable for it. Call it remaining. So this should be steps minus the Q movement. Let's do steps minus Q, the current position of Q. So now for target ball, how many steps should target ball move? So it should move the steps that is remaining. So we are using a variable called remaining, right? Target plus equal to remaining. So that's it. So this is the case when I mean the collision occurs. Now there are other cases when the collision doesn't occur. Let's code for it. So this should be because it doesn't keep going on only once. Now, when collision doesn't occur, what happens is the queue just completes its movement. Whatever the steps are given, it is less than the space between queue and target point. So the queue can just freely move the collision. So queue plus equal to steps. That's it. And the while loop gets completed only when the target reaches the target ball reaches the target, which is greater than equal to 8. So when it does, we should print it again. Print it of q comma target. That's the logic. Now let's complete this function. Define it outside the main method. So we are passing the queue's position and target position. So they're both integer values. So here in function, we are just defining them again. You can use any variable you want. So we can define the size outside. So they're taking the access totally. So I'll put it over here. Since we're not going to be changing size, let's say it's static and final. Things, I mean, it is final, so it cannot be changed. Size always remains 9. So less than size I plus plus. So if you look at this case, the Q position is represented as 0, and target position is represented as 2. But all of the positions they are just points, I mean dots. So if I equal to Q, we are going to be printing, oh no, not print, print. We are going to be printing 0. Or if I is equal to target, we are going to be printing 2. If it is neither Q nor target, it's going to be just a dot. So that is for this else case. And once looping completes, we are leaving a new line. Let's execute it and see if it has any errors. Okay. Missed it here. It's board of careless errors. I'm using println in some way. Yes, for dot I've used println. So let's run it again. Yes. Now let's test this second test case since it is seems simpler. 2, 3, and 5 are the inputs. First I'm giving 2, next I'm giving 3, next I'm giving 5. But I give 2 comes here, it moves one step. I'm giving 3, it comes here 1, 2, 3. No, something is wrong. Where am I missing? What am I missing? 3, 1. Oh, yeah, it's working fine. 2 steps. 1, it goes from zeros here, it comes here. On the 2, it comes here. So 4 dots are remaining. 4 dots are remaining. That's right. 3, 0 comes here, and 2 moves the remaining steps. The 2 more steps. So 2 comes here. There are 2 more dots. For 5, 1. Let's try it again. 4. I think there's some mistake. Target less than size. Okay, remaining is not steps minus q. It should be actually q. It's not the actual position of the cube, but the number of steps that it is going to move. So that's the problem in the code. Let's run it again. So let's give the first test case. Let's give the first test case. 5, 3, 4, 2. Oh, a lot of input. 5, 3, 4. First three inputs. 5. Yes. But moving. So yeah, that's the logic. I mean, that's the output, and that's the code. I'll post these on my GitHub and leave link in the description. If you want, you can check them out. So this is my approach. So if you have a better approach or think it can be optimized, let me know in the comments. We all make mistakes, and I can be wrong too. Let me know them. And the thing is, we cannot use collections, and we should use it only using array. It will be given in the bottom. We don't using arrays. So that's the thing. And if you have a better approach or think it can be optimized a bit, let me know. I'll try to improve and cover it too if possible.
Hi guys, I'm Uday Krishna. I'm a final year CC student. If you think you learned something from this video, like, subscribe and share it with your friends. And thanks for watching.